So in order to understand our universe, a basic force in our universe is the force of gravity. So for instance, right here, we can see actually two galaxies that are gravitationally interacting. Is that not cool or what? And remember that these are like islands of stars way far away, and so kind of that wispiness you see here, those are actually stars in and of themselves. So I just think that's a beautiful. What would Isaac Newton say if he could have seen that picture of those two galaxies gravitationally interacting with each other? But even without seeing some of the things that we can see today, Isaac Newton actually came up with 3 laws of motion now, general laws of motion. And Kepler, earlier on in this course, we know came up with 3 laws of motion that govern how the planets orbit the sun. But Newton's laws are more general. I will say that Kepler's laws are consistent with Newton's laws as I understand them. So we need to take a look at Newton's laws of motion. And like the slide says, I am just amazed how those laws apply to, on a small scale, gravity that holds things here on Earth to the Earth, and on a large scale, the dance of galaxies we saw a minute ago. So in order to get a feel for the laws of motion and gravity, we need to understand motion. So there's a very general way of talking about your motion. That would be, you can tell somebody your speed. And if you say you're going down the road at 30 miles per hour, that means that in 1 hour you are going to go 30 miles, okay? So that's your speed. Sometimes we use speed and velocity interchangeably, but actually velocity is a different cat. Velocity not only says how fast you're going, but also says what direction you're going. So velocity gives speed and direction, and it's what we call a vector quantity. So we could use arrows to indicate your speed. We could use arrows to indicate your velocity. So for instance, if you are going this way, we could call that 30 miles per hour, and we would call that what, east. Okay. If I double that length, okay, that means twice the magnitude, and I go in another direction, so that would be what, 60 miles per hour north. Okay, so we can use vectors, and actually the cool thing is we can add those little vectors and come up with what we call the resultant. But anyway, so velocity is both speed and direction. And then the last thing we kind of need to touch on, because it's a player when it comes to how objects move and gravity, is acceleration. So acceleration, you're probably most familiar with, if you're driving down the road, you hit the pedal called the accelerator. Okay, so that makes you go faster. And if you don't, so it makes you increase your speed. But acceleration is a change in velocity. And remember, velocity has 2 components. So we say that actually it can be a change in, and in physical science we use the symbol delta. That means change in. It can either change in speed. So like if you hit the accelerator on your car and you're going straight, you go from at rest, so 0 miles per hour to 20 miles per hour. So you have accelerated from 0 to 20. That is actually your change in speed. Or acceleration can also be, since it's a change in velocity, and velocity has a direction component, if you change your direction, okay, you are also accelerating. Okay, change in direction is a form of acceleration. So here's a figure from your textbook with a car doing a number of things. The top one is clearly you can see it's going from 30 kilometers per hour to 60 kilometers per hour. The change in velocity, the change in speed, okay, we can do a subtraction, so it's going 30 kilometers per hour faster here. Okay, that's its acceleration. The next one is, notice that the car, it starts out at 60 and it ends at 60, okay? But what it's doing is changing its direction. So if we were to kind of draw an arrow down the middle of the car, okay, it's going that way here, that way here, that way here, okay? Can you see where those arrows are pointing in different directions? You know, if you compare this arrow with this arrow, it has definitely changed directions. So this change, even though it's going the same speed, okay, now the fact that it changed directions, this is acceleration. So let's see, what do you call this? Going around a curve, okay, just a curve, okay. Or if this was going a full circle, what would that be? An orbit, right? Okay, so things that are in orbit are always accelerating. And you know where we're going with that, because we see a lot of orbital motion in astronomy. So orbit equals acceleration. Smiley face. The last one down there actually is decelerating. Deceleration is definitely a change in velocity. So here it's going from 60 kilometers per hour to 0 kilometers per hour. So the change in speed or the change in velocity is 30 kilometers per hour. This actually would be a negative acceleration. So negative acceleration. So Newton, these are going to be kind of important general concepts when we talk about Newton's laws of motion.